So it's time for our last major type of hypothesis test from Chapter 10. And that's the one for a standard deviation and or variance because they kind of go together hand in hand. Now notice how radically different these steps are from the old ones. Just kidding. They're very much the same. All right, but it's still got to be a normal distribution. It's still got to obtain simple random sampling. But now we're talking about sigma or sigma squared that kind of go together, right? So just keep that in mind. Select your level significance. You've got your test statistic, your chi-square. Now notice, though, that these are not normal distributions. These are chi-square distributions. So they have a different picture. And that's okay. And then step 5, step 6, just like before. So let's do it, shall we? All right, so the graduate records examination is a test required for admission to many U.S. graduate schools. Students' scores on the verbal reasoning portion of the GRE follow a normal distribution with a standard deviation of 120. Suppose a random sample of 10 students took the test and their scores are given below. Is there sufficient evidence to conclude that the standard deviation is different from 120? All right, so a couple of things. One, it's a small sample, but that's okay because they tell us that it's normally distributed. If they didn't, we would have to go do a normal probability plot of this data and double check. But they gave it to us, so life is grand. So let's begin, shall we? Step 1. All right, so we need some null and alternative hypothesis. We also need an alpha, but they gave it to us. Alpha is 0.05, so I can just type that in right here. And then they want different. That's a two-tailed test. So let me go up here. Let me grab this. There we go. All right, and you know what? It occurs to me that I didn't tell you to do classical or p-value, so I guess we'll just do both and see what happens. Let's start with the classical. So, oops, I grabbed the wrong thing. I grabbed test statistic, which is not what I meant to grab at all. Oh, there it is. Okay. So we want to know, is sigma equal to 120 as they supposed? Or sigma not equal to 120. And let's just take a moment and realize what this means. This means that sigma squared would be equal to 120 squared. Let me go find what that is somewhere. Let me grab a new sheet here. Oopsie. Okay. Equals 120 squared, which would be 14400. It's helpful for these problems to keep both of those in mind because sometimes Excel or StatCrunch will do one or the other, but not the sigma or whatever. So this would be sigma squared is not equal to 1440. So they kind of go together. It helps to know both of them. At StatCrunch, I believe, needs the sigma squared one, if I'm not mistaken. All right, step 3. And then we'll do step 4 the classical way. And then we'll come back later and do it the p-value way. All right, step 3 is the test statistic. Whoops, I just went right by it, right there. All right, so test statistic, we're going to need, well, we're going to need s. I mean, look at this thing. So we're going to need n minus 1, we're going to need s squared. So n minus 1, we happen to know because this was 10. There were 10 scores there, so it's 10 minus 1. And we already found the bottom one, but I'll write it again. It's 120 squared. Oops. Okay. And then we need to go find s. So we're going to need to take this data and put it into an Excel spreadsheet. But I think I already did. Let me go see if I can find it. There it is. Okay, so the standard deviation, which is s, is equal to stdev dot s, or stdev if you've got old school Excel. There we go. So it's 105.446. Let me type that in. 105.446. All right, now let's find what this is altogether. So let's type n, which is count from here to here. There we go. Sigma sub 0, which was 120. So chi-square. Oh my goodness. Statistic is equal to, parentheses, 10 minus 1, close parentheses, times s squared divided by 120 squared. There we go. There's our test statistic. All right, I'll meet you back here to keep going.